first question will be something to do with a block on a plane. So, we've only done this 1,000 times, right?
Right.
So you should go back and look at all that. You should be able actually to derive the equation for the acceleration of the block down the plane. Don't you think, by now? Nope, absolutely not. There'll also be a conservation of linear momentum. And there'll also be conservation of mechanical energy. You guys remember 1/2 mv squared plus mgh equals 1/2 mv squared plus mgh?
Yeah.
Yes? And there'll be couple problems with the material we're going to do today and Monday. So something to do with chapter 12.
So there is no chapter 10 or 11.
I just had a test on that.
Yeah.
Right. So these are the three sort of comprehensive problems, and then there'll be 2 on chapter 12. They're not going to be hard. One of them's going to be probably something we'll talk about today, which is linear expansion. When you heat things, they stretch, and when you cool them down, they shrink. Yes? We're going to talk about why that happens and what things influence how far they stretch and how far they shrink. And then this one will be something to do with Q equals MC delta T. You guys have seen this?
Yeah.
Heat is equal to, oh, there's something else there. Mass times, what is this thing called? Heat capacity times delta T. That'll be the 5th one. We'll talk about that, and then there'll be a change in length problem. So that's the essence of what the final will look like. And we can talk more maybe later today and definitely over the course of the week, okay? So go back and look at your notes. You guys should really be, and you should really be able to derive without numbers, I think, by now. You know this is mg, right? And if this thing has friction, which way is the friction acting? Up. Probably up, right? Because it wants to go down. And so realize that I can decompose the weight into perpendicular to the plane. We talked about this, and parallel to the plane. And then there's, of course, a force normal. So if I want parallel forces, let's define the probable direction of motion as positive. If it actually moved, it would probably go down the plane, right? So we'll define that as positive. So what forces are down the plane? Down the plane.
mg.
All of it?
Times.
Some of it. Remember, this angle here is theta. What component is along or down the plane? Sine theta, right? So mg sine theta minus the force of friction, which is up the plane. Remember, I defined this as positive, is equal to, if it's actually moving, it's probably ma, right? That's the acceleration that would be parallel. And in a perpendicular world, this way, let's define this as positive. What is up perpendicular to the
Force
plane?
normal.
What is it?
Force normal.
Force normal. Force normal. And what is down into the plane.
mg cosine
mg
sine theta.
cos theta, and that equals 0 because it's not levitating. It's not levitating and it's not plowing into the plane. Equal forces here, yes? So realize that from this equation, mg sine theta minus mu force normal equals ma parallel. See this? I can take this information, put it right there because of this equation. You guys got this? Minus mu mg cos theta equals ma parallel. It's like magic. It's like magic.
Do you do birthday parties?
I do, and I make balloon animals. What do you notice about this result?
M cancels.
The m cancels. It's independent of mass. What? Isn't that crazy? What are the units of G? What are they? G?
Kilogram? No, gram, no, kilogram.
G. Meters per second squared. U, G, cos theta. So hey guys, look at this. I can figure out the acceleration of the object down the plane if I know the angle and if I know the coefficient of friction. We already know G, it's 9.8, right? So realize that this acceleration is some fraction of 9.8 depending upon the angle and how much friction is on the ramp. And if there's no friction on the ramp, what happens to this guy?
Cancels.
It goes away. And it's all about the angle.
And friction.
Here. If mu is 0, that goes away completely and it's all about the angle, right? And if the angle is 0, how much acceleration does it have? 0. It has no incentive to move. If the angle was 0, it'd be sitting just like that, wouldn't it? What if the angle's 90? Then there's no friction. Well, actually, it doesn't matter. What if the angle's 90? It's gonna drop like G, isn't it? Pretty cool. Pretty cool. Hey, by the way, I think I gave a problem like this, didn't I? Or did I? Conservation of momentum on the test. It's going to be two-dimensional. 2D, which means you need two sets of equations. Which two? We're going to pick on what?
X and Y.
X and Y. I need an X equation that says mv equals mv in the X direction and mv equals mv in the Y direction. I need two equations to solve this problem properly. Some people come up with some kind of weird alternative solution, but I better see two equations when you set it up. Okay. We can talk more over the course of the week. Conservation of energy, total mechanical energy, that means 1/2 mv squared plus mgh original equals 1/2 mv squared plus mgh final. Think of the Jamaican bobsled team. Yes. At the top of the hill. At the top, all their energy is
Potential.
potential, and at the bottom, it's all kinetic, and then somewhere in the middle, it's
Equal.
a combination, not necessarily equal, right? But a combination of the two. Yes? So if you read this problem carefully, you'll be fine. If you read this problem carefully, if you read the problem carefully,
We got it.
you'll be fine. Do you?
I do.
Okay, and then we'll do some of this stuff today. So that's what you can expect. Start studying now. It's a week from today. I'll be here Monday and Wednesday.